Hello, calculus scholars. Today we're going to be doing very basic differential equations. Now, if you like this stuff, there's actually an entire course that you can take in college called differential equations. It's actually required if you're going to be an engineering major, math major, physics major, because you actually see that differential equations are used when you're kind of modeling different types of equations and predictive models, like the COVID-19 model, for instance, and how many cases there are. So I actually want to start by defining what a differential equation is with a very basic example, even more basic than what's on your notes. So when I introduced integration, I gave you a problem where I said, dy dx is equal to x squared. And then I said, what was the original function? And we learned that we could figure that out by this exercise of taking the antiderivative. So what we actually did when we took the antiderivative, before we took the antiderivative, and you may kind of notice that when we integrate, we see that there's a dx. And some of you may have wondered, why is there a dx? So you're actually going to find out today. So our goal is not to get the derivative of y, but rather the antiderivative of y. So when I do that, I take the antiderivative on both sides if I want to do that. So take the antiderivative to one side, I must do it to the other side. So the antiderivative of the derivative of y is just y plus, some type of constant c. I'm just going to call this like c1. And then on the other side, we had 1/3 x cubed plus c2. Now I'm kind of, being a little bit nitpicky here. I mean, this is really what's technically going on. You're getting like two different constants. But when you're getting y by itself, the c1 and c2, kind of combine to form another constant. So we just kind of put our answer, with plus c at the end. So when we get y by itself, I get, 1/3 x cubed plus c. So we actually are kind of doing differential equations, when we're doing our, basic integrals. And part one, example one, really is about this level, except there's another term. So if I'm doing like example one of part one, I would first write this as dy equals to 2x cubed minus 3x. And we want to multiply both sides by dx. And then I'm going to take the integral on both sides, because I want the antiderivative of the derivative to get the original function. So I get y equals to, 4 times a half is 2. And I always like keeping that plus c in. Now, notice, we would get a constant on the dy side and a constant on the x side. And this is a well-behaved differential equation because we have a y on one side and the x is on the other side. So you want to make sure that, you're doing that. Example 2 is a little bit harder level because we have like maybe something that requires like a chain rule, or not chain rule, but maybe a U substitution type of deal. So I'm just going to get the dx on the other side first. Make sure that you are integrating on both sides, because we don't want dy, we want y itself. And to get there, you take the integral on both sides. Now, the left side is a piece of cake. That's just y. Right side is not as much of a piece of cake, but it looks like something that we're going to be doing the u substitution with. So I'm going to say that that's x squared du is 2x dx, of which x dx is just half du. So I'm just going to erase what's on top here to kind of continue our work, now that we've seen the basic example. So I'm going to write my integral as a u integral. Actually, before I do that, I'll just maybe put the x dx together. So sine of x squared. And notice I said of to emphasize that it's a u substitution. So this is the integral of a sine of u times 1/2 du. Put that half on the outside. And then you got yourself a nice basic trig integral. So the integral of sine of u. Well, think about this. So the derivative of cosine is negative sine. This will be the 1/2 negative negative 1/2, because the integral of sine is negative cosine. Make sure you put a plus c. Yeah, darn thing isn't showing up. So you have a negative 1/2 times the cosine. We'll just have to maybe make a little room here. Of x squared, that's our u, plus c. And then the other side, the antiderivative of dy is just y. So that would be your non-derivative equation. So if that's our derivative, our antiderivative would just be negative 1/2 cosine of x squared plus c. The next video we will be doing sort of the less straightforward differential equations where, we're going to have to be able to get the y's and the x's on the same side. And these are, what we call, separation technique. So please stay tuned for that.